Hello and welcome to Making Art with Khan Academy. So one of my favorite things to do is to start with just a blank canvas. This isn't blank because I'm going to start teaching you about recursion, because that's a very powerful way to create art in computer programming. But I love just like starting with a blank canvas, no error messages, nothing, just writing out some code and just seeing this beautiful picture pop up over here. It's almost always astounds me, like once because I start out with like a vague idea of what I want to do, and then like it comes out over here and it's this incredibly complicated picture I never could have imagined. Well, I probably could have if I tried really hard, but usually I just get a vague idea and I go with it. So ignore this for now. I'm going to first start by translating the screen so that the coordinate system starts right here. So that this is the origin 0, 0. Y will still be going down, X to the right. So you do that by writing translate. I'm basically saying translate 200, 200, but I like to use width and height just in case I want to make my art full screen. Then I don't have to go and redo all the math. Okay, so what a recursive function is essentially a function that calls itself. And they all have some kind of breakout condition, otherwise it would go into an infinite loop. If you ignore this and you say, oh, okay, I'm calling recurse, that's this function right here, and ignore that too. Okay, so somewhere within the definition of recurse is a function call to recurse itself. So it's going to look for this definition, which will have inside of it another definition that contains another definition that contains another definition, infinite depth, except for that each time we are passing parameters in. So usually what the breakout condition will be, it'll have something to do with I. And you can see that right here I'm calling recurse with I minus 1. And right here I'm calling recurse with 10. So here it will go into this block of code and I will equal 10. So it'll do this breakout condition, I is 10, and I don't want it to break out. I don't want it to hit this return statement. I want it to do my animation or whatever. Maybe you're going to do some kind of math, like I've seen like a factorial function defined recursively and various other mathematical functions. Oh, by the way, my idea for this, I think I have another program that does something like this, but just a really simple recursive ellipse. So instead of just calling ellipse with x and y and width and height, I'm going to call ellipse with iterator, and then it's going to draw 10 ellipses, and it's going to do some kind of rotation. So you'll get like some kind of spirally thing. Okay? So now let's talk about the breakout condition. Well, I'm calling I minus 1, so I is going to start at 10, and then in the next layer down it's going to be 9, 8, 7. So I think a good breakout condition is going to be if I is less than or equal to 0. Really, you only need like equal to 0 because you're pretty much guaranteed that that's going to happen. But this is good form, so I'll do that. So on the 10th layer of depth, the 10th nested recurse, we're going to break out, and all of those function calls will all come due all at once. Everything will get drawn to the screen, and we'll have a cool little spiral. So right here is where we need to write our block of code that may or may not deal with I. I might just be bookkeeping to figure out how many layers down we are in to. Oh, and by the way, if you leave out I, it's not going to go into an infinite loop. Computers aren't capable of that. So this language obviously has some built-in safeguards. That's called recursion error. If it goes so many layers down, then the larger program that's kind of taking care of this program will sort of shake its head and be like, nope, not doing it, and it'll just throw an error. Alright, so I said I was going to do an ellipse, and in fact I am going to have it depend on I, but remember I translated center, center, so 0, 0 is where we're going to draw our ellipse, right here at the origin. And width, I'm just going to have fixed at 10. Height is going to depend on I. I'm going to say 30 times I. So let's just check that and see what it does. So each time, each layer of depth, I was decreasing. So I started out at 10, so this is an ellipse that has 300 height. And then in the next layer down of the recursion, we have I equals 9, so whatever 30 times 9 is, 270, I think. Whatever. And then eventually we get down to I equals 1. That will be the last layer, so this one should have, yeah, that looks like 30. But then I equals 0, it hits return, and then the recursion breaks out, and all of those ellipses all get drawn all at once. Okay, so the next thing we're going to do is rotation. So to save the position matrix, you use push matrix. So this function just, if you've seen push in some other sense, it probably had to do with some kind of an array, like my blocks.push new block or whatever. Well, matrix is a linear algebra representation of the coordinate system. It's a matrix of effective transforms that have taken up to that place in the program. So this is going to save a matrix that says, oh, well, the coordinate system is down here. And then later on, I can do a rotation, which will take the entire coordinate system and rotate it by some amount. And then I'll have a new position matrix. And if you want to learn more about what that matrix looks like, it's like an array of vectors that when you apply it to, let's not get into that. I am not prepared to even lecture on that. So I save the position matrix, and then I do rotation. Rotate is a function that takes some kind of angle and it acts on the position matrix to give you a rotated coordinate system. So I'm going to rotate, I don't know, I think by I. So the difference between using this line and not using this line is pop matrix brings me back to just that translated coordinate system. It pulls that old matrix off of the stack of saved matrices. But if I don't use that pop matrix, then like we're just doing like a, I've been programming in Python. That's the delineator for comments in Python. So if I don't use the pop matrix, then I'm not pulling any of those saved matrices off. So that's the same as if we just hadn't worried about matrix transformations, and I just get all of those compounded rotations. If you want to deal with compound rotations, there's another thing that says reset matrix. So once you're done dealing with your compound rotations and transforms and what have you, you can do reset matrix. I don't know, right here might be a good place to do it, so that the rest of your program, whatever you have below here, doesn't have to deal with some arbitrary rotation. This puts it back to the default, which I think is an array of all zeros. I think there's like a print matrix function if you want to see what's in this stack of matrices, which you could find on the processing.js website. But I'm just going to leave that video here. It's probably getting closer to the 10-minute limit. Alright, see you all later, or I won't see you because you'll be watching this on YouTube, but leave me comments, ask for other types of art, what have you. This is going to be a playlist of making art on Khan Academy. Thanks for watching.